Hello everyone, I Supriya Panda welcome you to the video as a part of the assignment of machine learning using Python codes from Skyfi Labs. So I used Jupyter Notebook to perform this machine learning project by using Anaconda Navigator. So by installing Anaconda, then I use the Jupyter Notebook, and it is very easy to use, and it is used it is very familiar. It is used by most of the people to perform various projects. So then let's start. Here we will take the housing data set, which contains information about different houses in Boston. This data was originally a part of UCI machine learning repository and has been removed now. So we can also access this data from the scikit-learn library. There are 506 samples and 13 feature variables in this dataset. The objective is to predict the value of prices of the house using the given features. So let's get started. First, we'll import the required libraries. So first we import NumPy. NumPy is an library used to handle multidimensional arrays. It provides a easy way to vectorization operation. We used np to access the functions of NumPy. Then we import pandas. Pandas is an open source BSD licensed library providing high performance, easy to use data structures and data analysis tools for the Python programming language. We used pandas to load the data into data frame object. Then I import Seaborn. So it's optional. You can use install it, or it's not necessary for this project. It's optional. So then import matplotlib. So it is a Python 2D plotting library which produces publication quality figures in a variety of hard copy formats and interactive environments across platforms. So then we have to import matplotlib.pyplot. It is also a collection of command style functions that make matplot library work like MATLAB, and we use matplotlib.pyplot to draw different graphs and all. So then we have to just import accuracy source from sklearn.matrix. Then we just import function animation from matplotlib.animation, and it helps makes an animation by repeatedly calling a function. Then we have to just import load Boston from sklearn dataset. So the sklearn is nothing but the scikit-learn is a free software machine learning library for the Python programming language, and it deals like loading dataset, splitting dataset, uh, processing dataset, and model evaluation, etc. It performs various works that I mentioned. So here I just use train and test data model in this project. Then we import mean squared error. This function compute the mean square error between predicted and evaluated values. Then we just import a train test split, and this is also a function takes dataset as features and target and split them into two sets as training set and testing set. So we have to just import mean max scalar, and the mean max scalar is nothing but it helps in the transform features by scaling each feature to a given range. This estimator scales and translates each feature individually such that it is in the given range on the target set. So for an example, between 0 and 1, then we just have to import HTML. So from ipython.display, so this code reviews and understand of codes better. Okay, then we can see I just written Boston equal to load underscore Boston. So here I just load Boston dataset into Boston variable. Then I just print boston.desc_r. It is a form sklearn library. It is from sklearn library and helps this description when needed. So here we can see by running this, it gives the following dataset characteristics and different attributes, and you can see there is different attributes, like number of attributes is 13 and number of instances is 506. So this is the whole dataset. Here put the data into pandas data frame. So in the columns there is features, name of the features. So we are just loading the features into a feature variable, so in data frame, and data frame, and you know a data frame is similar to Excel workbook, tabular data sheet, and data structure which is used to store and manipulate its data, and it is the data structure native to pandas. The table starts from 0, and here you can see the index is from 0. Then we by running this code we got 506 rows and 13 columns in total. Then to see just one column, that is one feature of the dataset, let's age, then you can type such as feature age, then you can see the whole age column. It is also length 5 and 6, and data type is float. Then we just create a target variable and load the data frame consists of the target column in from the Boston dataset. So here we can see it gives the output the target column. Then just found the maximum value inside the target column. Here we get 50.0. Then we just create a data frame and concatenate both the features and target that we obtain above. Then by calling this data frame, it gives the output, as you can see, the whole data sets adding with target column. Then we just describe here the whole data set, and we just round up the decimal digits in the given features. So we just showing the decimals of two digit decimals. You can see here to simplify the data. Then here we add just correlation, like here we add just generate descriptive statistics that summarize the central tendency, dispersion, and shape of a dataset's distribution. So, mainly the correlation is a statistical technique that can show whether and how strongly pairs of variables are called. So, we know there is a positive correlation and negative correlation, and in positive correlation both x and y value increase simultaneously, and in negative correlation, if x increases then y decreases, or if x decreases then y increases. So, and you can note that an existence of correlation between two variables does not necessarily mean a linear dependence between the variables. So here we write the code like data frame dot core Pearson. It is the method. Pearson is the method to compute the pairwise correlation of columns excluding null values. We can see here we just written all those things. Then we we use lambda function, and then we use gif, and gif function takes multiple list and returns a list of tuples in which each element is a nth value in its list. So the thing that zip is an inbuilt function in Python that allows to combine multiple lists. So when we have multiple lists and we want to group the elements at the same positions, we use gif function, and here we use gif function. Then we are just a plot graph. So here in x-axis we plot attributes, and we take attributes, and in y-axis we are just taking correlation with the target variables. So here we can see we got a bar graph. Here the LSTAT and RM feature have maximum correlation with the target, you can see, and other features has not. Then we are just load the value of LSTAT because it is very highly correlated with the target value in x-axis, and target value is load into the y-axis. So if then normalization, so then we normalize the data, and normalizing is performed by using the min max scalar. So normalization is nothing but a simplified data. So here we have written x scalar dot fit underscore transform. So the fit transform is nothing but is to do some calculation and then do transformation, say calculating the means of columns from some data and then replacing the missing values. So for training set you need to both calculate and to do transformation. So then we got the value after normalization. So you can see the difference of value in before normalization and after normalization. So then here we use update function. So update function is used nothing to calculate and like its purpose is to calculate gradient and current position, and it update values of m and c, and here m is the is nothing but the slope, and here we calculate the values, and it returns the values of m and c. So here the parameters are current state of m and c, current value, then attribute value x, then target value t, and learning rate. So using a numpy vectorization operation, we can write the step like equation, then we update the gradient. So here the can note that we multiply gradient by learning rate. The return slope intercept c, which controls how much weight change. Then we just here we then define the error function. So the purpose of error function is to calculate the cost function at the current position. Here is also the parameters are m, x, c, t, and x is the attribute values, t is the target value, and current values of m and c, and m is known as the slope and c is the line intercept. So it also returns the error values. Then we just define function gradient descent. So gradient descent in machine learning is a optimization algorithm to minimize a function. So it is impossible to gradient a space consisting of more than 3 dimensions. Therefore, iteratively move in the direction of steepest descent. So, uh, the learning rate is the size of the iterative step, and if gradient descent is too low, requires many steps although accurate, and if is the value is too high, then might lead to divergence. So the function to be minimized in machine learning problems, the cost function. So there is here we can see we used error, and here there is a condition that e less than error threshold. So if e is less than that the error threshold, then we got some problem. So we have to see that it must not very high or very low value. So then after print this error less than the threshold, stop the gradient descent, so it will stop eventually. Then by break the loop, then the append the error value. So here we can see uh, initial 0.9, then initial m known as the slope is 0.9, then that is also known as m gradient, and c is the intercept, line intercept, and here iterations, that is number of loops, is 250, and given error threshold is 0.001. So here we getting another graph, which also loss function is used, and it is the method to calculate how well our model fits the dataset. Difference between predicted value and actual value is also calculated and differentiated. So if the high value of loss function, then it is bad model, and if the loss function have lower value, then it is good model. So change in the loss function determines whether the model is improving or not. Then we obtain a graph. Then we are just learning a model by linear regression technique. So linear regression is a method has its origin in statistics. It is a method to understand relationships between input and output numerical variables. And this is also a supervised learning method. And this method is predicted output in continuous example, predicting stock prices or predicting the price of the house, etc. And this method is not suitable when the target is discrete, that is we cannot use linear regression model in classification task. So here first, there is various steps. First, you have to just assume an initial slope and intercept. Then in next step we calculate the error using least squares, and then apply optimization techniques, and then lastly obtain a best possible line that fits the data. Yes, we got a few ideas about linear regression.